Exponential functions. What makes these exponential functions is that your base, which is the a, is going to be a plain old number, but not 1, and x is your variable. So this is going to be the first time where you'll see that the exponent actually is the variable or has a variable. For example, if you look at this example I have right here, you'll see a bunch of information about rabbits. But here's the basic function. It says use y equals 220 parentheses 2.7 times 0.04t. I easily could have written it as alpha, in this case alpha t equals 220 times 2.7 0.04t if you want to write it in function notation. Either way. But look at this one right here. It says that there are 220 rabbits in August. Find how many rabbits should be expected by next August. The 220 is already accounted for in the equation, or in the function. But right now, if there's 220 in August, that means that we're starting with August of 1 year, and we want to know how many more rabbits there are by next August. So you have to use some real life thinking to be able to figure out how much time has elapsed. Now, since the rabbit population is growing monthly, we need to know, and this formula, this function is based on monthly time periods, how many months have elapsed from August of 1 year until August the next year. Well, if you know how many months are in a year, you should be able to figure out that's 12. So what we're going to do is we're going to substitute t equals 12 into our function. Now that means is, if I find f of 12, which just means substitute 12 for t. Now here's the problem. How do you find that? We got a couple ways based on our calculators. I'm going to do it with the graphing calculator first because it is easier. In some scientifics, you can also do it this way. So I'm taking out my graphing calculator because I'm a big fan of it. And I'm going to type in the function as I see it. 220 parentheses 2.7 close parentheses. And if you're wondering what the exponent key is that you need to use, it's this one right here. That's your exponent key. Now watch this. I'm going to hit parentheses again because I got two numbers in my exponent. I'm going to type that in all at once. 0.04 times, I'm using the times symbol in this case, the asterisk, times 12, close parentheses, and then hit enter. That tells me I'm going to have approximately, well, it says round to the nearest whole number, so I'm going to have 354 rabbits. So the only issue is do you know how to use your calculator? Now let's say you have a scientific calculator. First thing you want to do, after you turn it on of course, you want to find the exponent, 0.04 times 12. You get 0.48. Now what you want to do, let's go ahead and find 2.7, and we're going to raise that to 0.48 power. Now this right here, that's why the x key, that's your exponent key. So I'm going to raise that to the 0.48 power, hit equals. Then I'm going to times that by 220. I'm following the order of operations, in case you're wondering. So times 220. And we also get 354 point blah blah blah, but the nearest whole number, it still gives us 354 rabbits. So it's safe to say if you know how to use your calculator, you should be alright. Now one major application of exponential functions is compound interest. Standard equation for standard formula for compound interest is a equals p parentheses 1 plus r over n to the nt power, where a is the total amount, which includes principal and interest. It's like a banking account, savings account. You deposit money in, which is your principal, and you earn the interest. R is the interest rate converted to a decimal. N is the number of compounding periods in a year, and t is the number of years. So the main thing that you have to worry about is the n. If it's daily, we'll use 365. Some banks use 360. Weekly, in case you didn't know, there's 52 weeks in a year, 12 months in a year, 4 quarters in a dollar, so 4 quarters in a year. Semi-annually is twice a year, and annually is once a year. So that's an example based on this. Probably want to keep that formula close to you if you don't already know it. I got two questions here. One is compounded monthly, other one is compounded quarterly. So let's do the compounded monthly problem first. But we're going to use the same formula for both. So the first one, well, the both accounts are invested. We're investing $4,000. That's a one-time principal. And the interest rate is 4.1%. To make it a decimal, move it two places to the left. So that's 0.041. So we're doing monthly first. How many months are in a year? 12. 12. And then how many years? T is years, so that's 3. So once again, it's just a matter of, do you know how to find the answer with your calculator? Once again, I'm going to take out my graphing calculator because I like it. Here's how I type it in. 4,000, parentheses, 1 plus 0.041 divided by 12, close parentheses, exponent key, house type key, caret key, and then put the exponent in parentheses, 12 times 3. Close it, hit enter, and you get $4,522.59. $4,522.59. Now if you have a scientific calculator, hopefully you know what 12 times 3 is. Hope you know that's 36. That's the first thing you want to do. So by the order of operations, do what's the parentheses first. So let's do 0.041 divided by 12 because you do division first, and then you add the 1, and you get that. Then you raise that to the 36th power, and you times that by 4,000. See that? Gets the exact same answer. Keep that in mind. That's how you do it, step by step. Now let's do the second part, compounded quarterly, because we've got two questions here. We've already done the monthly. This one's the monthly. Now let's do quarterly. Now you gotta remember what quarterly is. How many quarters in a dollar? 4. So use the same formula. P still 4,000. Quarterly, or the interest rate still 0.041. 4 quarters, 4 times a year for 3 years. So once again, take out your calculator. I'm going to show you something that you may not be aware of. If you notice, it's the same thing except for the 4. The 12 became a 4. If you were to hit on your graphing calculator second and then enter, you'll notice that that previous item that you typed in is there. What that means is I can now go and change the 12 to a 4, and then we hit delete. Delete's right here for any extra number I have. 4, delete. See that? And we get 4,520.71. And what this proves to you is that the more times you compound in a year, the more money you're going to make in interest. Not a lot, but hey, something's better than nothing, correct? And once again, use your scientific calculator the same way you did before. 4 times 3 is 12, so you'll do 0.041 divided by 4 plus 1 raised to the 12th power times 4,000. See that? And that's how you do it. Main thing is learn how to use your calculator.